We are live. You guys have any questions? Last time we did word problems, guess what we're gonna do today? More of them. All right. What I'll do is just grab them from the book as we did before, because I want to do exactly the same kind you'll have. Hope we got somebody going good. So let's grab from Alex. Yeah. 3, 4 is what I'm gonna do. All right, today is more of the same of what we did before. Although I am going to probably do the first couple just to get you started. Yeah, we could probably do that. Okay. First, let's start with these ones. Those will be necessary for what we're going to do. Do you remember how to change a percent to a decimal? That is one way. All right. Well, look at this. Do you know what 1% is? What is it? As a decimal, it is 0.01. Right? If I do 16%, that's the same as doing 16 times 1%, correct? That's the same as doing 16 times 0.01, right? Which is 0.16. So all the stuff that you told me is never practiced by students. Instead, they memorize which way the decimal goes. So can you tell me what is the rule if you just pay attention to where the decimal goes? Two places. That's not good enough. Right. To the right. So move it 2 places to the right and you got the decimal. Because when you do our problems, a lot of these problems will have percentages in them, so you're going to have to do that. On your calculator, most calculators have a percentage button on them, but most people don't like to use them or don't even know how to use them. So we've invented, well, not invented, but we use this instead because it causes a lot less issue. What about this? So again? No, it's gonna be different. That decimal's gonna move which way? The decimal is moved, but did I say on the last one that moves right to left? As I get older, I'm not gonna know. Between like right and left someday. It moves to the left two places. So if they're going two places back and to the left, this thing is gonna go 1, 2, and the new decimal will be over there, won't it? There's your decimal. You have any questions about this? You done this before? So all the problems we have in here require usually a change from percentage to decimal. Because while percentage is useful for reporting things, people don't like to work with them generally. Now an application of the actual percentages. Go ahead and try that and tell me what you get. If you have no idea what to do, that's fine too. Anybody think they got it? Yes. What'd you get? 20.15? This, now look at this is helpful in terms of equations and solving them as well. Did you know that line right there, that sentence or that question actually is a full sentence? Did you know that? It has a question mark behind it and everything. What does the word is mean? Equals. So I can do something like this. Right underneath it, I can practically write the equation, like what would be X is 31% is 0.31. The of is multiplication. So all you have to do is 0.31 times 65. The sentence wrote itself. The equation wrote itself is what I'm trying to say. And that equals 20.15. Here, try another. That was a rhetorical question because I'm going to put another one up anyways. Let's see if I can find one just like it. I have number 9 is just like it. They vary around a little bit with these equations. So they move stuff around a little bit. So they're not all exactly the same. So now this you can do identically to what I just did.
Anybody 7.28? Good. All right. Now you see what I'm talking about, the next one. They start moving some stuff around, so see if you can deal with it. Anybody care? What you got? 250. So tell me, where does the equals on this equation? Right here. First thing you should always find is the equals. The numbers, they speak for themselves. You don't have to do anything to translate those. 12% is 0.12. What does the word of mean? Multiply. And what number? How do you solve that equation? Both sides divide by 0.12, right? So for your one answer of 3.6, that tells me that you multiplied instead of divided. So you should, I mean, last time they didn't have you solve anything. You just had to multiply, but then they went and mixed things up and had you solve an equation. I'm gonna grab a few of these till you get comfortable with them. If you get comfortable with these, then you'll have the makings to be comfortable with some of some of these word problems. So in these problems, let's try this again. What is the key word in these problems? Is, because it tells you what? What does the is tell you? I'm sorry, it tells you where the equals is, right? So yeah, look at that sentence and you can literally, underneath that sentence, write an equation that you can solve. To save you a little bit of heartache, what is that 8.4% when you convert it to a decimal? 0.084?
Comes out pretty nice. No decimal in the answer. You guys get 180? 180?
So we have 0.084 times X equals 15.12. Divide by the 0.084. And we end up with X is equal to 180.
Couple of other things where they move stuff around on you, and then we can solve the problems in the homework.
Is it 40%?
No. But 40 is definitely part of the answer.
Well, y'all got 0.40.
Mm-mm.
I mean,
Oh, I'm sorry. I was not reading it. Yeah, you're good. You're good. You guys get 40%? Sorry, that was my mistake. I was thinking I had a decimal looking at, but I was looking at the actual answer. You guys get 40%?
Once again, we locate the equals, which is right underneath the is. So this time they didn't have a percentage. This what percent, you'll have to put X in that spot of, put the 225 here. Divide by 225. And let your calculator tell you that this is 0.40. Which changes to a 40%. This question asks you for the percent, not decimal. I got one more of these types of problems. You want me to do it before I start the heavy word problems? Okay.
There's plenty of odd numbered ones in the book. If you want practice on this kind of stuff, and you are looking at the textbook, did you know each of these odd ones has the answer right there? All you gotta do is click it and it'll let you know. All right, we'll do number 18 and then we'll move on after this. Let me hide that one. Anybody want to volunteer? 125, 125%.
So we got right underneath of it. What percent that would be X?
Times 76 is 95.
And then, convert that to a percent.
Anybody think they have the answer? 9073? What's the first thing you figured out?
Being tax, tax is this. Tax equals 5.5% of $86. What do you say? How do you figure out that tax? What do you do to figure that out? Well, yeah, correct, sorry. To multiply the two together, that's right. So move the decimal place, make this 0.055. Change the other to a multiplication.
So, what was 473 you said?
That's just the tax. Gotta get the price, the cost. I don't know, what do you call it? That's the price. Plus the tax. So we would have, the price was 86 plus 4.73. That equals 90.73. And so we're talking about money, I'll put a dollar sign on it. Any questions about that? This is probably not that bad, because you guys, anytime you go out to eat or whatever, you gotta do something like this, that's not that big a deal. But you can see that this portion of the problem was just part of it. So the problems we were doing completely, the majority of the problems we were doing were all like that. And that was to prepare you for this, where you're gonna extend that capability.
Anybody? 650? 650? No? I'll take a look.
The dealer paid $101.95. And goes on to tell us that this was 30% of the original price. So isn't it true that those two things together say that 1.95 equals 30% of make that, it's practically an equation now. What is an equation? 0.3 times, I don't know, X for the price. Then solve it, what do you do? Both sides by 0.3. And the left side should have come out to 6.5. We should change it to dollars and cents, that's $6.50.
15%? Anyone else? 15? Okay, good.
So the connection was that markdown was 345, and that represented, I don't know what percent. So we wanted to know was 3.45. That was the markdown. Was what percent? Of 23.00. Would you agree that that's what the question was asking? So this can be made into a question. I mean, an equation, 3.45 was the same as this. What percent is X times 23? I don't mean 0.00 for this. Divide by the 23. And you get 0.15 equals X, but we need it as a percent. When was the last time you read the newspaper and said things are marked off by 0.15? That's not, as I said, percent is very useful in presenting information. They're not really used for working with it, but presenting to the public, it seems to be, people really like that because people have a comfort feeling for them. That's what should hear. This weekend only 15% off, stuff like that.
What do we have all together here? Estimate my time. Oh, we got more than enough. Okay. I'm afraid of running out of problems. I don't want to run out of problems. But I do want to move on. These are all practically the same style of problems. So this will be the last of these two, and I'll try to find a different kind for our next one. $120? Maybe I was premature. 120? 120? This is a little bit tricky. This requires a little bit of logic. I don't know if that requires that much logic, a small amount of it. If you're paying 20% off of the regular price, aren't you paying 80% of the regular price?
So what I would like to do, a little statement right here. This was 80% of the regular price. It's 20% off. You are paying 80%, aren't you? This here, what is that this we're talking about? This right here. That's the this. So we have 96 was 0.80 times the regular price I'll call X. And then divide by 0.80. Good. Okay. The 20%, I don't know, I was looking at it, and I was trying to figure out how the 20%, how I work directly with the 20%. And I'm not sure because I don't know how much it was marked down. So I don't really think I have an equation that will involve the 20% right off the top of my head. Let's do one more before your break. But before you get, before I let you try to work it, I want you to think about what I did on the previous problem. What percentage? If I say there's a drop of 15%, what percentage of employees are still remaining? Keep that in mind as you do the problem. Actually, no. They tell you the drop, don't they? Yeah, if they tell you the drop, then that's different. Sorry, you don't have to do the 85%. I misled you.
We think they got it? Yeah, I don't think it's supposed to come out to a decimal, so I think they made a mistake in the problem. Let's change the number of people to 138. Change it to 138. We're gonna fix the problem on the fly. Did they say, oh, that's what I was looking at actually in the problem, to say, round your answer to the nearest whole person or something, and it doesn't, does it? No, it shouldn't come out. Did it say anywhere, is there anywhere in here that says approximate? No, it wasn't. So this 136 employees represents 15%. I'm gonna change it to 138, so it works out all right. Yeah, you get 920 then. This right here. This way, we see 138 is 15% of however many employees of, I don't know, the original number of employees. So from that, then we get 138 equals 0.15 times X. Now when you divide by the 0.15, you'll get a whole number, which is the only acceptable type of an answer for this problem. Unless they said a rounding, because a lot of times, especially in the news, they'll never give an exact percentage like that. They'll say approximately 15% or something like that, and that's a different question. They said approximately, then we could have done this and added around, like you said, but they did not. So we have 920 is equal to X. Make sure you make that change in the problem, or in the problem, or this version is no longer correct. All right, let's go ahead and take 10 minutes there. Come back at about 2 after. What? I wonder. Huh? What does? They do, this one? Where? Oh, they might, yeah, I didn't really pay attention to that.
just, so you know, simple interest does not exist in real life. It's a fantasy. But we use that problem because it's simple problems for us to do. The way simple interest works is this. The interest looks like this. The interest equals I equals PRT. And these are all multiplied. P times R times T. So there's three different letters over there. I stands for interest. The P stands for something called the principal. Do you know what that word means? Not the guy who works in your school.
It's like the rates, right?
No, the amount you put in,
Oh, the month.
your deposit.
Yeah.
That's what you meant? Yeah, it's your deposit. And then R is the interest rate. Change it to a decimal, all right? Change that R to a decimal when you work with it. And then T in years. Rate as a decimal. That's the formula for the amount of interest that you earn on these things. I'm just gonna bring it up just because I saw the next couple of questions have problems like that. You guys catch those things? U is 11,000, R is 0.07, T is 1. The amount of interest was 11,000 times 0.07 times 1. That's from the formula I equals P times R times T. See, I've got 770. So the interest was $770. The other reason we probably do it, simple interest is because it's the only one of the formulas that's easy to do. The ones for compound interest require more math than we have in this class.
All right, let's move on. Problem number 42, this causes some issues with students, so we'll see how you guys work on it. I'll do it in full detail, but let's see how you do it. 522? 522, beautiful. That one wasn't as hard as I thought then.
So you have two different things he's putting money in. Total interest that you get, you have two different accounts. He took $6,000 and put it into a 5.2% account. Well, it's hard to say at the time when you do it, because that number may not have been there.
Right.
So usually you only find that stuff out after you've invested. And to be honest, this amount of money, I don't think would get these kind of interest rates.
Yeah.
This is the way you set it up? Oh wait, in each of these, I have what? PRT. People are looking at me like, you did not do this?
Separately.
So there's one principal, right? That's its rate. And it was in for 1 year, right? Well, the total amount would be plus, wouldn't it? So then you've got that 3,000 and you multiply by 0.07 for 1 year. Just to make sure that you all did that. So this turned out to be a total of 522. So it's $522. What part did you not have? I'm interested to know, because I don't want you to go down a path that you luckily get some problems right and then but it doesn't really work.
The only difference I did the two problems separately.
And then you add them at the end, right?
Yeah, so
That's okay, that's fine. There's no issue with that, yeah.
it's not 9%, it's 312.
And yeah, I just did the one thing you did, like, you know. Okay, I just wanted to make sure you didn't do something that would cause issues.
No, that sounds fine. What if I had, I'll tell you what, I'm gonna change the problem if you don't mind. Hey, where'd you go? But I'm gonna put it up, I'm gonna leave that one there. I'm gonna put a new one, but I'm gonna edit it, okay? I need large font. Oh, look at that. Do you see what they did to me? How cruel is that? Oh, let's do it this way. Now try it. I think I have what I need. I'm gonna take this out of here and delete it. I'm not sure I heard what did you say? Yeah. So yeah, you put 6,000 on the one and 3,000 on the other. Notice the time is different this time.
This is how you can do it all in one line, or you can break it up into two pieces like you guys did. This time, you're multiplying, T is different in both these situations. That's how you can do it all in one shot.
If I do it all in one shot, I ended up with 3,240. Do you guys get 3,240?
That gives us 3240.
By varying, it allows me to see that you guys did know what you were doing. All right, move on to the next. Something different about this problem than the previous one? What don't they seem to tell you? Nope, it says 1 year. I know. That's what we had. We did that in the previous problem. We did this problem. Why is it different than the previous one? That's exactly right. It's not telling us how much they're putting in there. Here you were told 6,000, they said the rest, but you knew it was for 9,000. So what do we do when we have a situation like that? We have this kind of a situation.
How much, who's the Angelica? So she is investing $15,000 into what we know, but we don't know how much she's doing. So she's got $15,000 total. We don't know how much she invested at 5%, so I don't know that. It's not a bad idea to call that X. rest of it was at how much percent? Can you give me a description of the rest? We spent a half an hour in class doing this on Monday. Exactly this kind of things. And you don't remember? That is absolutely not answering your question. You guys, you don't remember that if we had a total and I used estimate for one thing, the rest of it was this. So what it is she is gonna put X dollars into the 5% account and this amount of dollars into the rest. How much does she have in interest? They told you interest, didn't they? They told you the interest this time, so the interest was 680. And if I do my PRT for each of these accounts, the one isn't a P, it's an X. And the R, what was the R with that one? 0.05. And for how long? 1 year. And then the other principal, we don't know what it is, but we know that it's called 15,000 minus X. So that's a principal. Times 0.0, what's the other one? 4? 1 year. See those PRTs? Now, the method you guys are using to solve the previous problems would fail you for this. This is not two separate problems. You have to have it in one equation. Let me multiply this all out. That one doesn't be much. Then I'll have 15,000 minus X times 0.04. Remember that you should distribute, you should simplify before you do anything on these equations. So I'm going to distribute this through. I know that 4 times 15 is equal to 60. It's not 6,000. I believe it's 60. I'm 60. I believe it's 60. Tell me, if I multiply 0.04 times 15,000, you get 60. It's 600? I'm thinking, sorry, let's get, my brain's turning much, that 4% is 4%. Yeah, that's right. Minus 0.04x. Then over here, I had 0.05x. Now I'm ready to simplify. I can finish off the simplification on the left, on the right side. The 0.05 minus 0.04 is 0.01. So we have 0.01x plus 600. That's equal to 680. You see, no matter what the type of equation you get is, it always comes down to this, doesn't it? And now what are you going to do next? Subtract 600 from both sides. So I got 80 equals 0.01x. What should we do now? Divide by 0.01. I don't know if you know this, but that means to add 2 zeros to 80. 8,000 equals X. Well, once you know X, you know both of them, don't you? How much did they invest total? 15,000. So if they invested 8,000 in one, how much was left for the other? 7,000. X was which one? 5%? So we can write this as 8,000 at 5%. And then what was left over? 7,000 at 4%. So he, in the end, looks like he invested more wisely, doesn't he?
Questions about this? I'm gonna let you try another one of those on homework, because we've done enough of these. I'm gonna go and move on to a different style. Mixture problems are not pleasant for anybody. I'm not sure how I want to explain it, because I try every year to make it comfortable with students, but I have a difficult time making them understand. We'll see what I can do this year. Doesn't mean I quit trying, I just lament. All right. How do we do mixture problems?
Remember, for interest, we were doing something like this. Right? We're doing P times R times T. More importantly, this section is focusing on stuff like this. R times T. R times T is a very important thing. Rate times time. That's a lot of different meanings. Like for instance, isn't distance equal rate times time in all these problems? But that R times T or something like it, and R can be an interest rate and T can be time. That is so crucial to all the math. There's so much math. So, what did I want to say about this? How does this go to mixture problems? Is what I'm trying to say. So let's take a look at a common example. Something you see all the time. I can't fit all of Budweiser on the beer. But I happen to know, because I wrote them, that the alcohol content in a bottle, in a can of Budweiser is 5%. How much liquid is in one of these cans? So we forgot what's in a can. Well, that's right. I forgot. We don't buy cans much anymore, do we? No, we buy from the 24 pack though, don't we? 48 pack. But when it's the vending machines, they don't sell those anymore, do they? Like very rarely. Like Walmart, I think, still does. They sell it like Sam's Cola or whatever it is for like 25 or 50 cents. Whatever. All right, fine. It's 12 ounces. So these cans have 12 ounces. And we use OZ for ounces. All right, I want to know how much alcohol is in that can. How many ounces of alcohol is actually in there? How much alcohol is in that can of beer? How do you do it? That's the gist of what I'm getting at. How do you determine how much is in there? Well, here the formula is a little bit different. Now we take 5% and I multiply it to the amount. Times 12. It's multiplication. Because the alcohol, think about this. The amount of hot, I'm going to write this separate down. The amount of alcohol is 5% of 12 ounces. So when I write it like this, where's my equal sign go? Alcohol, I'll let A stand for the amount of alcohol. 5% is 0.05.
0.6.
0.6 ounces. You guys with me? So that's how much pure alcohol is in a can of Budweiser. Let's try a similar one. Anybody know how much? You go to buy a, let's stick with alcohol, or if you go to buy a bottle of wine, how big that bottle is? $750 milliliters. Or about 25 ounces. 7, I think, or something like 6. Okay, bottle wine. 750 milliliters, we'll go with that. And contains 12% alcohol. How much alcohol is in a bottle of wine? You see, the percentage is way higher than the beer. Wine is far stronger. Here I just milliliters is fine. So what do we do to figure out how much? What do I do to do it? So I take 0.12. Do you understand that a percentage? Actually, let me erase that for a second. I'm going to erase something before that. When I do 12% times 750, this here is my R. And this isn't T, but nonetheless, it's doesn't really matter. It is a number. So I don't know, R times what an amount? The format is exactly identical to R times T is what I'm getting at. So when you do this, you're going to do 0.12 times 750. And what did you get for that? 90, I will take your word for it. 75 plus 15 ml. Well, one way to look at it is this. If you were to take the wines that people do cook with wine, and if I were to pour it into a pan, and I don't think it has enough alcohol to light on fire, but let's say it burned it until all the alcohol burns off. They burn off the alcohol because what's left is real good flavor. So let's say you burn it off and all the alcohol is gone. That means that when it all is said and done, you will have 660 milliliters of grape juice. You understand? It'll be the best grape juice you ever had. I don't know why, but when they turn alcohol and then they take it away, it's really tasty. I don't.
It converts it back to sugar.
It's something like it. There's obviously something that goes on because it's incredible. All right, let's move on then. So we get the idea here. So you can see how much you have. This formula is basically, it's the same formula for all the problems in this section. Let's go ahead and do 54. And we'll see how, if you're ready for it. Because what I did is just like a little intro, and the problem itself is going to seem way harder than what we've been doing. But we'll see, give you a few minutes. If you don't do anything on it, then we'll go over it. You guys got it? Anybody? Well, it looks, if I were to guess, it doesn't look like either, anybody in here is even close to getting us. Am I correct? All right. You're on the verge of it. Should I wait till you get there or? No, just, okay, so, all right, let's take a look at it. It's not different, much different from any, it's not different than the problem that we just did that involved the money. Remember the RT kind of thing? It's exactly the same kind of a problem. Here, how many milliliters? Let's call that how many milliliters? Let's refer to this, if you don't mind. That's because it's asking us that, right? Would you tell me what this one is? That's, they're two different quantities. Not a Y, is that what you're thinking? Another letter, you could do that, I guess. All right. We have a total of 300 milliliters, right? Milliliters. Some of it was called X. What was the rest of it called? In fact, the X was 1%, 8%. The rest was 2%. Am I correct? So we took our 300 milliliters and we divided into X amount at 8% plus, what's the other one? 300 minus X at 2%. So it's identical to the previous problems. Now I've got my RT backwards though. I've got like a TR, but that's, I'm going to fix that in just a minute. I get 0.08 X plus, what's this one? Six minus 0. Oh, I made a mistake. Do you see this? See this? Let me fix my thing. That should be 300 times 0.04. That was my bad. So notice they're all of that RT kind of a format, right? The left side just becomes 12, I believe. Check me on that. All right, what would you do next? I would simplify. Yeah, I combine the x's first. So I'll get 12 will equal 0.06 x plus 6. Subtract 6. So then we get 6 equals 0.06 x. Divide by that. This is 1/100th of that, so this is 100. So we've got 100 milliliters of blood. That's 8%. This one's 8%. What was the other one they were mixing? The 4% was the final. What was the other one they were mixing? And how much was left over for 100 milliliters? We have a total of 300. Notice too that when they mixed them together, did you notice that they got some sort of percentage in between the two?
That's generally what's done. If you have a strong solution of something and a light solution of something, you can mix them together to get anything in between you want. You want it stronger, put more of the big one in. You want it lighter, put more of the little one in. Probably heard of bars that take and put water in their liquor bottles because people generally won't notice it, and they'll save a lot of money because water is way cheaper than liquor.
That's exactly right. That's right. There's probably an art to get just the right amounts to keep people drinking. The good bartenders are really good at it. All right, one last one. Due to time, I think I'm going to have to probably. I want to grab something that's nasty looking. And I hear that it's not nasty. Let's just do this. This is a different kind of a mix problem, but it's no different than the other ones. It just seems different because it's not liquid. But it's the same idea. It's still mixing things. And you've probably seen this before. They do it also with higher priced and lower priced stuff. If you go to the store, and like when I go to the store, I will not buy a bag of cashews because I don't want to spend $100 for a bag of cashews. But you might buy a little can that has a mix of cashews and undesirable peanuts or less desirable stuff, and that's a lot cheaper, isn't it? That they're mixing the super expensive cashews with super cheap peanuts and whatever other stuff is in there. Same thing with coffee. I don't think it's any different here. You get coffee blends all the time. What do we have? We have aromatic coffee. That's $6 a pound, and we have a hazelnut, which is $9 per pound. Should be mixed to make 3 pounds of the smooth blend. So we have 3 pounds. This is what we want to achieve: 3 pounds of the smooth blend, which is $8.75. So in the end, they want 3 pounds at $8.75. So they want 3 pounds at $8.75. All right. How much of the aromatic coffee did they use? What letter did they use? Choose X. Times, how much is the aromatic sell for? I guess you said aromatic. Next one. Tell me what the next piece looks like. This is where you come in now. You can do it. I know it. I can feel it. You've got it in you. The other amount was times. That's the more expensive copy. 9. I need that one. How many pounds of coffee are there total? So how many pounds of coffee are there total? 3 pounds. Doesn't it say 3 pounds? I've got an underline, don't I? If he's using X amount for one, what's left for the other? No. Three minus X. It's the same problem. These are all, you're fighting me on these, I know it. This here is 3 minus X, because the total was 3, wasn't it? Total from end to end was 3. The X one was the $6 one. And the 3 minus X was the $9 one. See the setup? 3 times 875 is 2625. I'll put 6x because that looks more reasonable to most people. Is that right? Did I do it right? 6.25. I'm getting up in years. You should not take what I say for granted.
Now, on the right side, I'm gonna get negative 3x plus 27. And over on this side, 62.25. 26.25. Subtract how much? Subtract 27, yep. So 26.25 equals negative 3. So on the left side, I get negative 0.75 equals negative 3x. You divide by negative 3. And that gives me 0.25. So they used a quarter of a pound of the cheap stuff. 0.25 pounds of the $6 stuff. You remember the blend was almost $9, wasn't it? So it should be a lot closer to of the expensive one than the cheap one that we used. And in fact, how much of the expensive stuff was used then? 2.75 pounds of the $9 stuff. If the price had been like $6.25, then the answers would have been reversed. Okay. That's all I got for you today. Hopefully there'll be questions next time because all you have is work from.
Here. Stop the recorder.